Hello, good afternoon. Hello, Bamero, and hello, Jim. How are you all doing today? Just let you know, I do take seriously what we have been learning together. I do appreciate your patience with us and teaching style. Thank you for the streams and chat. Well, thank you for that. It's always nice to have everything work. Am I peaking again? My mic seems to be pretty high up. Does the mic sound good? Sounds okay? Okay, good. I have the window on half the screen so I can have YouTube chat on the other half, and therefore the difference between not good and good is not very big. That being said, I am going to have to mute to open this. Because that's loud and right next to the mic. Okay, so all right. We're on to the fun stuff today. Now, if I remember correctly, we left with a lot of broken code in here because we just copy and pasted what we had previously, and now we're updating it for this stuff. And I had a thought last night, maybe less of a thought, maybe more of a concern. It's like, how am I going to launch and run the game from this? It's gonna be one of the things we're gonna figure out. Do I not have any errors anymore? That would be shocking. Okay, so while successful is empty, I score. Okay, so score everybody. Then then mark if they're successful. Okay, so basically we need to do the generation thing, don't we? Oh, right, that's what I was doing. I was looking through what we were doing. We have the old generational code, the genetic code to look through. So basically in here, we run a generation. So that's the next thing that we're working on. That's the current thing that we're working on. And generation is here. And so the first thing we need to do in generation is do a selection. In generation, okay, so first thing, do the selection. Okay, so we take our mute population, we take the graded retain percent, non-graded retain percent, our target X. So like what good is. Except, oh, I don't need the target X, do I? Because we already know the score. So I don't need that. Okay, so we sort the population by their scores that they now have. Keep count. Okay, so this is going to be this population. And then the keep ungraded account, same thing. Okay, then we keep this amount. So keep keep from zeros to the beginning. So keep a slice of the begin ones to now selected. Get a random number generator. Then we're going to keep until the end, choose multiple. And so then we have choose multiple. And that's how many. Okay, this is actually from choose multiple is from RNG, which is nice. So then we map that to owned and collect it back again. Okay, so there's that. Then we have our selected. We combine them together with concat, and then we return selected. And so you're upset because we're not returning a vec of strings anymore. We're returning a population. Okay. So generation, we don't need this answer anymore, which means we need to go to main and fix that. Oh, we're not even using this yet. Population is not a vec of string anymore. You're a population. You want ownership of this, don't you? I think that's okay because we return I get a new population back, right? So I should just be able to give this, like, give ownership of the population. Because I get a new population back right here. Well, I guess no. We're going to create a new population. So this is maybe previous population. Okay, so we get our survivors from selection, which we just looked at, right? Yes. We create the children, which is going to be a vec of something, which is going to be the individuals. RNG. Okay, so while children length plus survivors length is less than population length. Okay, so our original population. Ooh, I'm surprised that this is working because I gave ownership of population, didn't I? So I want let's just save that aside and we'll just do this here. Okay, so as long as the children length and survivors length added together is less than the population length, then okay, so we get parent 1 is go from survivors and choose a random one. Parent 2, okay, so we get 2 individuals. And now we need to make crossover work. Okay, crossover, we get okay, so we have 2 individuals, so individual 1 and 2, which, oh, these are okay, so those are 2 individuals. What did I do? And I'm going to return a new individual. Okay. All right, so the way to cross over this. I kind of feel that I want crossover to actually be a function of the individual. So if we find individual, I kind of want this to be like a new version of new. So this is like new from parents. So we have like parent one. Now, I was thinking about this because previously we had a string and we just took the first half of the string from parent one and the second half of the string from parent two. But they said that you can do all sorts of different things when you're combining these together. Because we just have a single number right now, I'm thinking about just taking the difference between them. So halfway between. So if I get our force X, I want the difference between that. So if I get these two together, okay, so let's and then we'll get the absolute value of this. So this is, I guess, like the difference. So if I subtract this from, oh no, if I add this to like the lowest one, it will be equal to the second one. So I want half of this. So I then want to know which one to choose with. So we're going to do lowest, I guess. So lowest parent force X. I think there's a way to do this, right? Where I can say parent one dot force X dot min returns the minimum of the two integers. Okay, so then the other is going to be parent. Two. So I want the smallest one of these, and I want to add half of the force X delta. And that's going to be the child's force X, so. And then we'll just create a new self. Okay, so we have force X, our end position X. And these can be the zeros. Like where it got to. And what its current score is, it's scored at 0. Okay, so now we have the new from parents. Which means, okay, we don't have to do the crossover like that. Okay, so this creates a new child. So then instead of this, we'll do individual, new from parents, 1, parent 2. Okay. That's great. Okay, so then we do a mutate chance. So I guess this is another thing that we can control inside the individual. So we can do a we could do a mutation chance, then do a mutate off of it, because the individual when it's born has a chance of being mutated, or at least, you know, I guess we can mutate it. So okay, mutation chance. Maybe I don't want to put this in here. Maybe we just throw this in here. You know, and actually that kind of feels like it's from crossover too. I kind of like that. We just say like, okay, what was the other? The mutation chance is if we mutate, we get a random character Oh, I just change one of the characters over to this random character. We have a single thing. We're going like even simpler than we had here. So I feel that in this case, our mutation should probably just completely replace what this is. So here's what I'm going to do. I'm going to say, so let individual equals, we create a new self like that, and then we're going to return individual. We're going to make you mutable. Let's see. Okay, individual. Blah, 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 blah. Okay, so then we can have mutate in here. And we don't change. This is just going to. This is going to be one of those like, okay, what's the mutation chance? So we can actually pass in here mutation chance. And this should probably be a probably an F32. We should. I was doing like just choose a number between 1 and 1,000 or 1 and 100, and then choose like 1 from that. I should really find out. Oh, I need to pull in. Okay, can you tell me? Ooh, no. What's the... Oh, what's the trait that I need? Is there like a prelude? I don't remember anymore. Oh, apparently yes. Okay, so this gives me I think this is giving me a number between 0 and 1. One would have thought that it would have been outside of 0 to 1 if it was allowed to go outside. Okay, so we could just do this. Okay, so we'll have a mutation chance coming in, number between 0 and 1. And then we create the individual. So we'll do if, okay, so here's where we do, so I want to do the mutation chance in here. So I kind of want, I'm creating like RNG multiple times. That's not great. That might slow this down, especially if I have a large population. I could pass in RNG. That would be better. Let's do that. Yeah, okay, so we'll have RNG, and that's going to be a mutable reference to a thread RNG. Okay, so then we'll do if I want to create a, let's say, okay, if I do mutation chance is like 10%, as long, okay, if the number is below that, then we're fine. So I just generate the number. So if the number is less than mutation chance, okay, so if rng.gen is less than mutation chance, then self.mutate. Oh, it's not gonna be self.mutate, it's gonna be individual.mutate. And then return to individual. So we know we're mutating. I think in this case we just set the number to a random number now. So we're gonna take in type. Okay, fine. I figured it would be able to figure that out. I guess it can't. Okay, this one I figured it out. All right, so you're happy in this file, so we can go back to you. We don't need mutate anymore. So in generation, we don't need to calculate. Okay, so we get the child. New for parents. We have to create, okay, so we have this RNG. We have to pass that in here. Mutation chance. So we need to pass that in here. Okay, so you're happy now. So we don't calculate mutation chance. We don't do that. The child is either mutated by this time or not. Albert, hello. How are you doing today? You're resurrecting your old laptop. It's struggling to run Twitch and Thunderbird and updates at the same time. Oh no. That can make sense. Like decently old enough, and stuff takes a lot of memory. Okay, so we push the child into the children. We extend the survivors with the children, and then we return survivors, which means we're returning a population. Okay, so I think this is generation working. Okay, so go to main. So this scores the population. Then we want to create a new generation. So we're gonna just do population is gonna equal to generation. Okay, what do you want? You want the current population. So population. You want the graded retain percent, the non-graded retain percent, and then we need a mutation chance. This is going to be 0 dot maybe 1%. And that's it. That sets the population. So okay, that generates a new population. So it kills half of them, and breeds the rest. I was given for free by 4 years ago. Yeah, so like not powerful already 4 years ago. Yeah, that I can totally tell. That would be it. That would do it. Okay, so we create a new population. What's next? So we get the generation. Then okay, in this case, it's just like, hey, do you have the answer yet? So we need to do the thing. So now we need to run the simulation and set the thing. So run simulation, set set how well each individual did. And then that's it. Then we're going to mark if any of them are correct, did it right. Actually, I think we move this down here. Is that right? I think so. Okay, so ooh, but no, okay, wait. How is this gonna work? So I'm getting the new generation, but they're not been scored yet. I need to run. Oh, you know what? I need to run the simulation at the beginning. See how well they did. Okay, so we need to do this here. Okay, run the simulation, see how well they did. Oh, or no. Okay, run the simulation. then score them. Oh, but the score is no. Okay, so run the simulation, set how well they did, score them, score each individual. Then create a new generation. Yan, hello. How are you doing today? You're right. That is absolutely correct. This is a 10% mutation chance. I wasn't even thinking. That's true. We should do that. Also, how are you? Okay, so create so let's say like create a new generation, like move time passes. Like a new generation happens. Then it's like check if any succeeded. This one is interesting. I don't know if this is any helpful because I did this after the new generation. I need to do this before the generation and then just exit out. Because if any of you are successful, then we're done. So I feel like I don't want to do time passes. So like we score everybody. Then we need to check to see if you're successful. Okay, so score everybody, check to see if you're successful. We could do generation count after the generation, that's fine. We need to, if we're successful, we're done. And this will be a if successful is not empty, I guess. Then we want to break. Which means that this can be just a loop again. Wait a second. So wait, if I'm on here. Oh, interesting. I hit tab. It takes me to the very end of this block. That's cool. Are you doing all good? Excellent. That's good to hear. Successful equals population. Okay, so then successful time passes. Obviously, like, we want to know how many generations did this take. And then, okay, so an individual figure out, okay, so then we get here and we're fine. So run the simulation. How are we going to do this? This isn't a module, so it has to play the simulation, right? We have to set. I think what I need to do is have like, right now it's like setting and doing things at the beginning whenever things set up. I think I need to have like a reset or something thing, and then it calls into the evolutionary code to sort of figure out how to play. I think that's what we're gonna have to do. So we have GGEZ. Okay, so when we set up new, I don't want to set up like a new force like this. We have like our entity. Okay, we don't want to even set up a new entity at this point in time or apply force to it. We're definitely not going to have entities like that. What we can do is we can have entities though. Okay, so we set that up. Now we have update here like that. I think what we need to do is I need to find out when we're done. And then we reset this and run it again. So what does that mean? That means I have to get the current generation. Is that going to be like a channel send or something? The BIOS had to reinstall stuff? That doesn't sound good. Okay. How is this connection going to work? This is what we're trying to figure out right now. So I need it. Okay, so here's the problem. I need it to, when we first start, ask the bot, give me all the information for the bots. But probably not like just once. I need it every single time. And then once we have those, we move forward. And then when we're done, okay, so we need a state machine. So our main state needs a state machine. We need to know what current state we're in the simulation. We're currently getting the new stuff, like getting the new weights, like creating the new generation of I guess like we're either running a simulation, the simulation has ended, simulation is beginning. Really, it's a binary, isn't it? It's running or it's not. Okay, so if we set ourselves up as running like this, then in update, if we're not running, I need to ask the bot for the next, basically the individual's forces. Like give me all those forces. This is not asynchronous. This is synchronous code. If I get one set, I wonder if, what do you all think? Should I use channels for this, or should I just have like a function that I call? Oh, and then how do we even call the bot? You would have immediately gone to enum for state because you might need it to expand it later. Any reason to choose simple bool here? The only reason for that is because I don't know what the other sides were. Like basically it's running and not running right now. So I feel that like Rust feels super easy to refactor with that kind of stuff. So I feel more confident in like just not going straight there because I'll just be able to switch it to an enum pretty easily later. That's the only reason. Yeah. I think we have a problem here. Not there. Okay, so we have this bot in main here, but I can't run this, can I? I need to call this. I need to call a function and like set this up from the game. So I almost feel like I need to switch this from main, like rename this file from main to lib, and then have the current thing that we have as lib do something else. So hold on, let's do this. What am I drinking? This is a passion fruit hibiscus tea. So it's a caffeine-free drink. In previous times when I'm like feeling really tired, I might have like a black tea or something like that. The Better Owen, hello. How are you doing today? Goku, hello. Okay, so let's rename lib. So let's move our lib.rs and rename that to I guess like it's the functions, like this is the core part of it. So I'm just gonna rename this to core because I don't know what else to write that. You gotta rename main to lib.rs. And then go back into in lib. I want to update this from main. Let's make this like run. I feel like I need to turn this into a struct. So we'll call this like bot. And I feel like these can be properties on this. Oh, you know what? I don't want to do this at all. What I really want is just this stuff here. So I want something like winning position. And you're an F32. Oh, this isn't gonna be use bot anymore. This is gonna be use we need a mod core. Like that. Okay. Bot represents the simulation itself. Not exactly. Win in position. Yeah, good catch. No, so this is gonna represent the bots themselves. So I guess not the simulation. We're gonna have the GGEZ simulation, and then the bots are pulled in by GGEZ, and then they, like, GGEZ asks it, hey, what do you want to do? What do you want to do? What do you want to do? Like each time through. I should really... Okay, so hold on. We can do this. Great. Grid retain %. That becomes an F32. This also becomes an F32. Generation count. This becomes a U. This could be a really big number, right? So let's make this a U64. I can't imagine it's going to be... Actually, yeah, I can't imagine it's going to be bigger than that. So we're just going to set that. Okay, so you're going to be in successful... You're going to be a VEC. I don't need successful in here at all. But I do need... Okay, mutation chance... You're going to be an F32. Also, everywhere that I have a semicolon, you become a comma. Okay. So then we're going to turn this into... No, undo, redo. I'm going to remake this main again. Okay, so we're first going to start with a new. And that's where a lot of this comes in now. I guess I could just delete these. Okay, so with new, we have winning position. Okay, so we set up winning position, population size. We create a population, greater retain percent, non-greater retain percent, generation size, generation count. We don't need successful, mutation chance, and then we're going to return a self, and then return this thing. So, population size. Why are you to-dos? Why couldn't you figure this out? Did I misspell this? Population size? No. Okay, you don't know where this comes from, so import it from core. Okay, so there we go. So now we have new. Now this one, this loop, I want to do this. It's not one loop, I just want one, like, run a generation. So kind of a pub function. This is like not one run one generation, but like, I guess like run. And it's probably not going to be run. We need to first, we want to do this thing first. So we're going to create the bot. So here, with this thing here, we now know we can store the bot in here. And this is going to be a bot. Okay, so we now have the bot. What I'm thinking of, if we're running false because we finished a run, then it's time for us to, we want to get the new, we need to create the entities. And we create them from the individuals. So what does that look like? We choose here. Okay, so the friction force, this all is good. So for like, slow down all of the entities. So we figure out what the friction, we create a friction force, we slow it down. Then we need to do a, we apply that force. And then we're going to update them. Okay, so and then, oh, and this won't be a self anymore. Oh, and the friction force needs to be per, so this actually needs to be in here, doesn't it? So we create a new friction force based upon this entity. We reverse it. We apply it to the, we apply it to the entity, and then we update the entity. And then you are going to also be in here. So after we update you, okay, so then we say, okay, entity, if your entity position X is plus your size is greater than the width, then bounce. Okay. And then we're done. But this is only going to happen if we're running a simulation. So if self.running, if this is true, then all of this happens. Otherwise, we need to create new entities. Okay, so create new entities. What font am I using? What font am I using? Is this Helix that I've got that set up on? No, okay, so it's not helix. That means it is alacrity. Okay, we're using Fircode Nerd Font Mono. Okay, so if we're not running, then I want to replace all the entities. I want to replace all the entities, right? So we start false on running, right? So if we're not running, then I need to get the entity positions. Okay, so I need just a list of forces, right? So in here, pub function like get forces, or like basically I want them to like play the game, right? So they want to like play. And we're going to return a vector. This is going to be based on the population, right? So I'm going to turn each population into just the force x. So a vector of F32. Okay, so for each individual, I want to return the individual the force x, and then we're going to collect it. Okay, so this is play. So I want to get let the force x, the force x is bot.play. Okay, so that gives me this. Tea Kettle Drone, hello. How are you doing today? Okay, so force x's, and then I can turn these into entities. So we can just say self.entities is now going to be equal to take a force x's, we might as well into iterator it. We'll map this. I want to create a new entity. New. Okay, so I need to give it an X and a Y. JJ, hello. How are you doing today? I'm using the Helix editor. Yeah, four sexes. Yeah, something like that. This is not correct. Or rather, I don't want to take ownership of this right now. I just want to create them as part of this, don't I? Oh, but I kind of can do this, can I? Hold on. We can do this. Let's wrap this in brackets. Okay, so we're going to start with let mute entity equals. Okay, so our entity is going to have this new entity, X and Y. So if I start you at everybody is like 25.0, 25.0. So they're all going to start in the top left, which is not that great. Helix inside the Zellage terminal multiplexer, which is inside of Alacrity. So like the triple thread of Rust, I guess. Triple Rust. Yeah, these top bars and the top and the bottom bars, and then these windows are all Zellage. Okay, so I create you, and then I want to create a force. That's gonna have, okay, so the X is gonna be the force X, and then the Y is gonna be 0.0. And then I want to apply the force. So apply the force, and then return entity. And then we'll collect you, but you should know what to collect into. Okay, so that starts everything off. Now we will run this, and everything should start in the top left and won't be that interesting to look at, but at least we should see different things happen. So that should be great. Do YouTube viewers get Twitch chat? Yes. In fact, way more often Restream bot works for YouTube than it works for Twitch. So way more often that they on YouTube are seeing the messages you're sending, you sometimes see the messages that they send. So I try to read them out loud when they come in. But you've seen the last three. Those were the only ones we've gotten so far. Okay, so entity. Okay, this is good. This is good. Then once we have our entities and we're good to go here, we're gonna do self dot running is true. Mark you true, and then we'll go through the next loop and everything will play. Okay, now obviously we have some problems. Unresolved import error. Why is that? We are in core. We did install error, didn't we? Oh no, we didn't install error. Okay, hold on. We can fix this. Twitch echo chamber. Yeah. Oh, and I don't. Oh, and they can't see emotes. So if you do Twitch only emotes, they'll just see the words for it. So they just see feels okay, man. Okay, so that's good. We do need to. Where do I want to mod from this? I probably want to mod from the library. And then from core, we'll use super individual. Okay, that's good. Pub mod individual. Yes, we don't need to do that anymore. The name create populations defined multiple times. Okay, so wait, did I do two create I did two create populations. This is the one that I think is the real one, and this is the one that is not the real one anymore. So we can just delete you. Oh my gosh, so many errors. Okay, so field, oh, an individual. Okay, so make you public. Cannot find value population in this scope. Okay, so oh right, main is just weird right now. Okay, so we do play that gets the forces, and then we're gonna do a pub function, I guess, like run generation, like run. And then here we need the results. So we need to know how well they did. This will have to be a vector of F32 in the same order that we have them, that we gave them here. So I guess the first thing is we have to set how well each individual did. So I think we can do this with zip here. I think that should do it properly together. What, I didn't give this a name. This is like how grade closeness close to edge. Okay. I guess let's make this plural. Let's loop through. Okay, we'll do self dot our population. We'll do iter mute. We'll zip in the close to edges. And then I think because it's iter mute, we zip. I think we just do a for each. Is it two things? So it's like A and B? Or is it one thing with like A, B? Oh yeah, it's one thing. So we have the individual and close to edge. So here I would just want to set individual this is your end position X. Okay. Hawk Max, howdy. How are you doing today? Okay, so when we run, we get how close they were to the edge. And then, okay, so that was good. Then we score you. Then we check to see if any of you succeeded. Now this one says like successful equals population. So what we can do is we can just say oh, population. This will have to be a self.population. Okay, and then our winning position. I think we have self.dot for that. Okay, successful. This is self.population again. Type annotations. Okay, so you're going to be you're a vec of an individual. Are you a... Okay, so it knew what it was going to be. Okay, that's great. Okay, so if we found a successful... Okay, so if you're not empty, then I actually want to... Here, we're going to print line... We found at least one individual who passed. Then we can just print off who that was. Then we do our population. Oh, I want to return. Also because like we're done. Like not just return, I probably want to crap, like I probably want it to end. Though that's gonna be interesting. Let's, where's exit? Center process exit, that's it. Exit, we'll do a 0 code. Uh-oh. Okay, I need to add this in before I copy that. Okay, so this is gonna be a standard process exit 0. Then we run the generation. Okay, self the population equals import generation. Okay, so pass it self the population. Be self for all those. Okay, that's great. And then generation count. Okay, we'll increase you. Okay, and then we're done with you. Oh, right. This is actually a better success message. I like that more. I feel like I'm missing. What's going on? Oh, weird. Okay, so hold on. There. Okay, I think that's much better. Oh, except you need to be, oh, successful. So you're just, okay, an individual figured out the correct force after, this is unfortunately self-generation count. Generations. And then the individual, okay, so we have self dot generation count, and then we can have the selected successful. Yeah, successful. And then you need to be like that. Okay, and then we exit immediately. Okay, population. Ooh, cannot move out of here. Now I am like assigning this, so I wonder if I want to do just something like this. Let population equals self dot population. We move you out because we're reassigning you here. Do you not implement? Oh, you're not going to implement copy, so we can just clone you. Okay. We have some errors. Wait, do we? Running should probably be an equal sign instead of a colon. Okay, yeah. It's a good thing. Cannot find width. Okay, so is greater than, isn't this self width? Okay. Oh, and draw is going to be the same thing here. So we need to do a for entity in self dot entities iter. We're gonna do our canvas draw. Okay, so then this will just be the entity, render with the context. Okay, what are you upset about? Expected. Oh, this will be no entity render. Oh no, you are a reference. Okay, that's what it is. And then instead of self, it'll just be, we get the position. Okay, okay. We're getting closer. Only warnings and errors now. Sorry, only warnings, no more errors. Let's see, you don't need to be mutable. Wait, are you also unused? No, you are used. You're just okay. Population size is never read. Okay, so we need to. Why am I not using it? Population size. We set the population size. Population size. This isn't here. Oh, because I just used the population size here. You're right. I don't need to keep this in here. Okay. We're getting closer. We never used that function. Okay. Height is never read. Okay, totally, you know, I understand. I could delete you. We're going to add that in later. I'm just going to go ahead and underscore you over here before you yell at me. And I guess we're not using you. No more warnings, no more errors. Okay, so here's what I'm guessing is going to happen. It's going to load up the game, and I mean, I don't know, like 50-50 on it just crashing immediately. But if it doesn't crash immediately, it's going to run through one iteration and then never stop. So we're going to get just like the initial loads. And I think that's going to be okay right now. We still have like a bunch of stuff to do here to like handle the next loop, to basically run the next generation. But that will be good. That'll be fine. So let's try it. So if I do a cargo run. Hey, okay. That's pretty cool. So we had, I think that's 10. That's 10 different individuals in the bots that sort of ran, and those were their initial setups. So that's pretty cool. Now what I would like to do is either put them all into the center. What do you all think would be cooler, like more interesting to look at? Them stacked where each individual is like stacked up and down so we can see them a lot better, or all together and then we just sort of see which one wins. Like we can give them like an alpha, so we can see through them too. We can give them random colors as well. Personally, I think the stacked approach might be better. You love the planning part and coding. It can be a lot of fun, especially when it comes together and then you actually see it work. I think I'm gonna do this stacked. So let's do stacked. So this is, now we're creating this and I'm just setting it to be the Y to be 25. I want this to count the number that we have. And then Y will be 25 times the index that we're currently on, the index plus 1. That way it starts with 1. Okay, so let's into iter, that's enumerate. We're going to take this count. Okay, so we're basically going to say let our y is going to be the index plus 1 times, we're going to have to parentheses this, times 25.0. And then u will be the y. Okay, so if we run that, oh, we have an error. You're 1.0. You still aren't happy. Oh, because the index is a U size. Okay, so we need to convert you to an as F32. Sure, that'll be fine. Nothing can possibly go wrong there. I feel like they're overlapping. Their height is 25. Oh, it needs to be 25 times 2. So it's actually times 50. Okay, I think that's a lot better. Imesdrin, hello. How are you doing today? And then, okay, so we need to, if we're running, we need to detect if any of them are still moving. You checked Helix earlier today? It looks nice. Yeah, I like it too. Like after you try it out for a while, let me know if you still like it. Okay, so 400, I want to now detect if anybody is still moving. So I need to know, I'm already in a loop. I kind of don't want to do another loop here. So I kind of want to that still moving equals true. Like this isn't a, I'm not sure how good, how much I like this with still moving as a Boolean, but like we choose if do we want to set this to be false? If any of them are moving, we're still moving, right? So, okay, we set this to be how about this? We'll just set you to be 0. And then I'll just increment this based upon how many are still moving through this. So we'll just do if how do I determine if you're moving? If let's add that to the entity. We have that velocity, we can use it. Okay, so if we're still moving, how do we tell? So if we have our velocity is I wonder if it actually ever gets to 0. I would imagine that it does, but it's sort of hard to tell. let's just assume that it does, right? So if self.velocity.x is partial equal to 0, in fact, then we can just return this. And then, okay, so still moving there. So we bounce you, and then finally at the end here for entity, so we'll just do if entity still moving, so if that's true, then still moving plus equals to 1. And then at the very end, so after our for loop, if still moving is equal to 0 after this point in time, I did this opposite. I did this very much opposite. Hold on. If you're not equal to 0, okay, so if you're still moving, then still moving increase to 0. Increase that. Okay, so if by the end of this, if none of them are moving anymore, then I want to mark you as done. So we'll do self dot running equals false. That's how we know we're finished with this thing. So now we're going to go into this else. So we go back and forth with this. Let's see if this works. Problem, some of those were moving really fast. So I have no idea how long it's going to take before any of them finish moving, because some of them might be like just still going for a while because they were, let's say worst case example, they started at 100 speed. We reduce it down by like 0.01 every frame. This could take a while before it reaches 0. I should probably also check to see if they're off screen. Like if they're off screen to the left, that counts as they're no longer moving anymore. So, okay, if the entity dot position dot x plus the entity size. Okay, so if that is less than 0, or the entity is wait a second, does this make sense? If you're to the right of the screen. Oh, that's what I should do. Okay, so if you are greater, so I should do minus. Okay, so if we can see the left edge of you still, and you're still moving, then still moving increases. Otherwise, you don't count parts of that, so you might. There you go. Okay, so let's see if this works. Only one stays on, okay? Now, how close is that to, I wonder how much it really is still moving. I bet it's still moving. So let's see. Okay, so if we're over here like that, I kind of want to also just debug the entity velocity dot x. I just want to see, what are you? This is gonna flood the log here, but that'll be fine. Near the end, we should only have one of these. Okay, so we only have this one still. Yeah, we can see it slowing down. So I need to check if it's zero within. No, it's not that large. Oh, that's weird. Oh, this is E. I miss it. It's printing out E to the -11. So yeah, okay. So this is the problem of checking floats, like especially compared to 0. So that's, you can't be that. So if self.velocity, that, let's get the absolute value. So if you are less than 0 dot, like something, some large number like that, like just the, like a really, really tiny number, that should do it, which means should be able to remove that debug. Oh, it didn't like that at all. Oh, is this constantly restarting after one frame? Oh, okay. So I've got an infinite loop here where this is constantly restarting. So if our, oh, I did the backwards thing again, didn't I? I wanted to set this to be you're greater than. As long as you're greater than that, you're moving. Okay. And now these are different generations happening. And so theoretically, we'd see it eventually start to converge on this, but it might obviously take a while. The other thing is, like, I think it was what, like 1200 generations to like get the string. Obviously it takes much more time for it to run each one of these, because it only took like a second or two, or maybe less than that, to run through 1200 generations. But I think they're slowing down. But like it's getting, oh, it's kind of hard to tell, isn't it? I think they're different. I kind of want to put a generation counter on it to sort of see the number of generations. Let's do that next. So we can, from the bot, in draw, we can get the generation count. Okay, so we can do, let our text is, how does this work? It's like, okay, drawable text object. An implement's drawable. Okay, so it can be drawn immediately. Okay, so we could do text new. And it wants this to be something. Okay, so that would be like self.bot. Generation count. Do you have to be actual text? I think it does, doesn't it? String from, okay, yeah, it needs to be a string, so we can toString. Okay, and then we can do canvas draw. Our drawable is going to be the text. And then we're going to do this draw param. So let's put it as a destination. I want this to maybe be like a 10 pixels over and all the way down. So like 10.0, 550.0, something like that. I think we're got 600 down, so maybe even like 580. Sylvie, you want to hang out more? Sylvie, what? He came in, said hi, and then is in. Come on, come over here. You can hang out. All right, let's try running this. That is way too small. Also, we're waiting way too long. Like, that's essentially done. Okay, I need to make the text larger. Can I do that? Can I say something like text dot... Oh, set scale. Okay. Set font. Font impl. Ooh, yeah, I don't think that's gonna work. I really want its size. Now if I do like scale of like what? Like 4.0? What does it need? Let's also go into our entity and let's remove a few zeros. Like something like that. Oh, that made the one smaller. I can barely see it. Did this work? That feels like it's standing still. Oh, but it worked. Okay, so I feel like I can remove another zero. That should be good. Is it between 0 and 1? I'm not sure how. This doesn't really, I don't know what this means. It's like, let's try that. Otherwise I need to set the font and then set the font size for it. That became invisible. I can't see it. Okay, so I want to create a text. Ooh, that's not all that helpful. Now I could hand it a text fragment. So whatever that turns into a text fragment. Okay, what's a scale? Oh, a scale is just a... Oh, so I can do something like that. So a px scale from. Okay. So let's do what they suggested. 24. Okay, we can make that a lot bigger. Like 64. Oh, okay. Now it's too low. I need to move it to like 500. I know we're getting close to something where I can leave going, and then we'll see whether or not it's working. Okay, so these all started with a very high generation count. Oh, but that's not incrementing our generation. Oh no. Either that or these are just all still the same one over and over and over again. Oh, it is still just the same one over and over again. They're never gonna improve. Oh no. Okay, so hold on. Okay, so we run play, that gets the forces, and then after the thing runs, we need to run on it. Oh, that's what it is. Okay, okay. We're getting close. So if we're running, we reach the end, we're running false, and then we want to self.bot run. So run the next generation, and then we need the closest to edges. We need to know how close to the edges each of them are to tell them what their scores are. Which means in order to do that, I guess it's just their positions. We just need their x positions. So the x's is equal to self.entities. We'll get an iter map. And I just want entity.position. Okay, I think that's it. No errors. Then we run and we go on. Okay, let's try that. Ooh, generation 2. Okay, so now theoretically, if I leave this running, so I probably want this to stop a little bit sooner. Although, like, I kind of still feel them running, so it might be nice to like let them actually reach the end. Otherwise, they might not actually ever get there. Ooh, look at that! They are all converging pretty quickly on this. So as a reminder, the goal for these bots, they're trying to just have an initial velocity where they kick it, and it doesn't bounce off the side, but it exactly hits the side. So I actually don't think this is going to work, because I think it's going to be the exact same problem that we have with the running. So we're going to have to go into our individual, and so we'll get our end position, but scoring it, our end, when we score our target X, that's actually from here. Our winning position is I want it to be here exactly. I think we're 2000 wide. Yeah, we're okay. So we're 1200 wide, and then half of the circle is 25. So really 50. So it's gonna be 1150, but then I need a little tiny bit of give to that. So what can we do for that? We want to go to you, so I really want you to be 11500. No, 1150. And then in an individual, so we get the target. Okay, so I want to I probably want to set like, okay, if our score is within a certain amount. So like if we do is there a way to like tell a float to restrict to a certain number of decimals? Like I like 0.01, I think like 1% or maybe less than that would maybe be okay for us. Like as I guess if it's like 0.99999999999, that's good enough for us. Oh, you know what? We don't do that here. We don't do that here. We do that in our main library. And run. Here, okay, here. If the individual score is greater than 0. Let's do 4 nines. So if you're greater than 4 nines, then you're essentially there. I think that'll be good. So now we can run this and we can see how many generations it takes before it finishes. Now, I don't actually know if it will end. I think it's going to keep on going forever. Like even after it gets them all, it's going to run it again. But it's working. Like clearly you can see them improving even after only a few generations, which is nice. It's like this one's going to be our top winner, so we should see that one again up here. Yeah. Yeah. Okay. So that's what it does. We resorted our path, and so whoever the winner is gets to be on top here. Already getting really close. It figured it out. It got it. 6 generations. Well, that was I didn't expect us to actually like have convergence happen in the same stream that we initially set that up. That's pretty cool. So an individual figured out the correct force after 6 generations. The force, it was just one individual that got it. The force was 11.50001, and it got very, very, very close to it. So that's pretty cool. Okay. So I think that means it's like 420. It's like almost perfect timing too. You can start looking at evolutionary algorithms next year. Yeah, this is pretty amazing. It worked the way we wanted it to too. Let's go ahead and commit all this stuff up. All right, so this is able to kick. So, okay, what do we do? A bot is able to kick a ball and have it barely, like almost touch. Have it get within a pixel or two from the right edge. Okay, so he's able to kick the ball, get it at right edge, within, within 10 generations, really. Because obviously if you run this on your system, it's gonna be different. It might take more generations, it might take less. It's all gonna be based upon the initial setup of that. Zephy, hello, how are you doing today? You love the videos? Well, thank you for that. I'm glad they're helpful. Okay, now before we end, I want to plan. So the idea I have with this project is we're not done with it. I want to start adding complexity to it, and then so we add complexity to the simulation, and then we add complexity to the bot to handle it. So do I set a seed? No, I don't set a seed. I'm not exactly sure how to set a seed for this too. I guess I could set a seed for the random number generator for the RNG, but actually I don't know how necessary that is, because the convergence should still happen fairly quickly. We could run it again. This should still happen within 10, I think. I should put this over on my Windows system, compile it for Windows, and then see whether or not I can put that as my a starting soon for the afternoon evolutionary programming explorations. Here at 3, we're getting pretty close already. The top one won, so it didn't learn anything this generation. Oh, but this one I think it did. So yeah, the guess is it'll take up until around 10, but okay, maybe not. Maybe this one will take longer. But it's clearly trying. It's clearly getting better. I guess we got lucky with oh, there was a mutation that happened. Oh, look at this. Okay, so this time it took 11 generations, but 1, 2, 3 individuals successfully kicked it. So that's pretty cool. Okay, so before I do anything else, let's go ahead and push this up. And then I also want to get Switch to create a branch to immortalize like this one. So if you're following along like in the future, and you're in the future and like this project is long done, but you want to like follow along, the branch I'm creating for this is we're gonna call this like stage 1, maybe like stage 1. I'm gonna push that up. All right, so stage 1, what that was, stage 1 is pick the ball and get it as close to the edge as possible. Now, what's one level of complexity that we can add to our bot? Right now we just kick it, so it's a single thing that our bot has. I want to add one more piece of data that it has now. So that could be like a Y, where it kicks it and there's gravity it has to deal with. Like maybe I want to kick it. It can bounce off the bottom and the side, but I want it to hit the like the corner, like the bottom right corner, like the CD thing, or like I'm not sure what I want to do. I want to add. We need two things that the bot has to take care of, like to keep in mind. And I'm not sure what that's going to be yet. I think we're gonna have to think about this, and just sort of tomorrow afternoon, we'll continue it there. So this was bot has to keep track of one thing, which is the force to kick the ball. Now here I want this to be bot has to keep track of two things, and I don't know what those are yet. With the full goal, so goal, create essentially a game and have a bot play it. We'll be doing this in increments, starting with a very simple okay, so it's gonna be like starting with a very simple simulation, and adding complexity, and also building up the bot at the same time. Okay, so that's the plan. That's what we're gonna do. I guess this is gonna be like what, a description. So let's do, so we have our tech. Let's do stages. We have stage 1, so we have our description. So we don't know what this is. So this is what we'll have to figure out tomorrow, or rather I'm going to think about this. And if you have any ideas, send it on either, I guess, like a comment on here, unless you're a member on YouTube, probably won't work. Because like this is going to be what I've been doing is I've been making the YouTube videos members only for like, I want at least 2 weeks worth of videos, sort of like in a backlog in case I can't stream for something. And then that way every day a new video releases. They're around, I'm not two weeks yet, but I'm getting there. And then, so if you have any ideas for this, send it to me in Discord or X Twitter is probably the two easy, like best places. Okay, so that being said, let's okay, so create a plan. And I will push that up. If you want access to this code to play around with it on your own, then let's see, let's double check. Yep, here it is. All right, and that you just need to be able to run Rust and GGEZ. I think this should run just fine on Windows, but obviously I'm here on a Mac, so I haven't had a chance to run it yet. But I might try that sometime before tomorrow. We'll see. So anyways, that being all said and done, this was a great success, and I'm looking forward to adding more complexity to GGEZ tomorrow. All right, so that's all I've got. I hope that you all have a great rest of your day, and I will see you next time. Bye.